Okay, so I'm going to go into a demo of what Total View is all about. So first thing is it's a very compact installation. So it's an 80 megabyte installer. It's going to download, install on any Windows OS. It has its own database built in. We use SQLite as a database, so it's compiled directly into the application. So there's less security problems because there's no exposed ports. It's also fully self-supportive, so you don't need to get a DBA involved and say, hey, can you create a database and can you get licensing? All that's gone. It's going to install and immediately get to work and go through and find all of your switches, your routers, your gateways, your servers. And as it finds devices, it's going to start digging into each device to find out not only what it is, but what its capabilities are and what sort of information it has to share. This information is stuff that any seasoned expert network engineer would want to know. So very quickly, we're going to put red dots in front of things that have problems. So we have a red dot in front of the Syrah switch. We can click into that switch and we're going to see all of the interfaces on that switch. We see interface 5 has a red dot and 4% packet loss. Now, just because we found an interface that has packet loss, most people would say, well, if that's a printer or a photocopier, I really don't care about packet loss to that, which is appropriate. But if this is a trunk port to another switch, or there's somebody's VoIP handset here, or this is a video conferencing unit, or there's a critical server plugged in here, that changes everything. So you want to find out what is affected by this packet loss. And to that end, we expose all of the CDP and LLDP information, if any, is present on these interfaces. We also have a fully integrated port mapper. Click on the Connected tab, and it's going to say, gee, that interface has one MAC address. That one MAC address associates with the HQ voice VLAN, VLAN number 110. This looks to be a Dell computer with this IP address. And, oh, wait a minute, that's the voicemail recording server. Okay, now I know what this computer is that's affected by this packet loss. I'd say this is a high priority problem. Let's go see what the problem actually is. We click into the interface and we see the utilization graph. We go down and look at the packet loss graph and say, yeah, this happened right around midday. Okay, that's bad. And below that, we have the plain English prescription. And here we're being told that we have a cabling fault. So it's that fast and easy to recognize that we have a problem on the Syrah switch, a problem on interface 5. The problem relates to packet loss. It affects this voicemail server. Here's when the problem started, here's when it stopped, and here's what the problem is. Now, one thing to recognize is that a lot of other network monitoring products might not even be aware of this problem, and they're going to say that the interface is healthy. Here's why they'd say that, and here's why we say it differently. If you click on View Error Counters, it's going to show all 19 of the error counters that we're automatically tracking. Other monitoring products, if they're even monitoring the interface, they're going to say that the interface is healthy because they're only looking at inbound errors and outbound errors. In our case, with looking at all the errors, we can say, no, actually, it's not that healthy because you're dropping a ton of FCS errors. You've got some deferred transmissions, some outbound discards. Oh, and by the way, here's what all of this means along with the configuration is you've got a cabling fault. That way you don't have to go crack open the books to find out what does it mean when you have FCS errors and you have no alignment errors on an interface together. We're able to tell you, you've got a cabling issue. If you had FCS errors with alignment errors, but no collisions on either a 10 or 100 interface, then we tell you, hey, you're on the full duplex side of a duplex mismatch. So it automatically interrogates and determines, here's what the error counters mean so that you get the root cause of the problem solved. We also have an engineer's library built in. Click on the error counter and it gives you the official IEEE definition, a more basic lay definition, and then all of the different causes as to where this can come from. That way, you get the problem solved quickly. One last thing to realize, though, is with all of these error counters collected on every interface of the network at every 5-minute period, what this means is if you drop or buffer even a single packet anywhere in the network, any point in time for any reason, we know about it. So if we put this together and say, okay, we had a problem just before noon today, and that problem happened between this user's PC and this server. Now, this could be a phone to a phone, PC to a server, video conference unit to video conference unit, any two IP addresses, and we can path map it to show here's how these two devices connect to each other and what happened along that path. Here's the PC. Looks like it's plugged into the Pino Layer 2 switch connected to interface 7. That interface looks perfectly healthy. Again, by our definition, perfectly healthy means perfectly healthy according to all 19 error counters. Other products, if they say that it's perfectly healthy, but it's only perfectly healthy to 2 error counters, sadly, you could have collisions going on like crazy and not be aware of it. Outbound, we can see it's going out interface 25, and there's some utilization, but there's not 100% utilization, so there's more bandwidth available, and there's no packet loss. So that's a healthy interface. Looks like inbound and outbound on the Syrah switch looks good. Outbound on the Burgundy switch, going out interface number 3, we can see right before noon, we were dropping 6% of the packets. So at this point, we click into the interface, read the plain English prescription, and get the root cause of the problem resolved. So it's that fast and easy to find out between 2 IP addresses, looking at all of the error counters, all the QoS, all the configuration, all the performance, you can find out which interface had the problem and get the root cause of that problem resolved quickly, no matter what point in time it happened. Other features we have is we have a dynamic network map. This updates every 5 seconds, so you have a live look into what link utilization is and reachability so that you understand what's going on with your network. We have an automatically generated network diagram. This will end up showing how your network connects. You can move elements around if you want to. You can lock elements in place. You can download all this to Visio, so you have a very quick understanding of what's going on in your environment. For all the devices, we have a lot of information automatically collected as well. Traffic levels, PoE information on switches, spanning tree information, inventory information, full internal descriptions. We can automatically back up configurations on devices, no matter what the manufacturer is. All of this information automatically collected. If you want to see the issues, anything that is broken in your network, you can go to the Issues tab and say, okay, these are interfaces that have misconfigurations, incorrect subnet masks, interfaces that are dropping or buffering packets. And the point here is that a lot of folks are stuck running networks that really are full of mystery. They don't know enough about their network. We figure if all of that information got brought back, analyzed, and then presented to you, you'd march through this list, and if you spent 10 or 20 minutes solving each one of these problems, by the end of the first week of deployment, you'd be able to say, I know everything my network equipment knows. We've got built-in Netflow. Any interface that's sending Netflow, you can end up clicking to see who was using bandwidth at that time, and it's going to show you all of the flows that occurred at that point in time. TOS settings, ports in use. Built-in IPAM. You don't have to separately license this. This is going to show you all of the subnets that are in use in your environment, how they're allocated. We integrate with Microsoft DHCP to show their scopes so that you can see statically assigned addresses and, down in the purple section, the DHCP scopes along with release times. Our telecom module will show you where your phones are. You get to track MOS scores, QoS configuration, see what's going on with SIP trunks as far as latency, packet loss, status, and also route path. That way, if you're curious to know how stable is this connection and what happened at different points in time that caused that stability to be bad, like huge latency spikes, you can be able to track what happened over time. We have a license unlimited call simulator. And again, this call simulator can test your network and find out what is the stability of the environment for sending voice calls through. So if I want to do a test call, it's as easy as putting in the IP address, and I can choose a G711 codec. Let's turn some DSCP on, and we can target anything that responds to a ping. So I can ping my local gateway, I can ping a firewall, I can ping the far end of my MPLS network and see what is stability to that location and back. Well, it looks like across my MPLS network here, I have no stripping of DSCP, so my DSCP tag is not being stripped. I have no out of order. I have reasonable latency. Jitter is under control, no problems with packet loss, and some good MOS scores. I can do a load test and find out, can we handle 6 simultaneous calls on this link, or are we going to have problems? Well, we get up to 6 calls, everything looks stable. Wonder what happens if we put one more call on this link. Can we handle 7 simultaneous calls? Well, the answer is no, because 6 calls was stable, but when we get up to 7, our latency is climbing up through the roof, packet loss is really bad, and our MOS scores just dropped off a cliff. I'm going to switch and talk a little bit about our security module. On the risks tab, this is our SecOps capability. So if you have a SIM or an IDS that says, hey, we found a suspicious IP address, you can just put that in here and click search. It's going to find that device and say it's connected to Syrah interface 23. We click here and we can see, okay, 10.0.0.10 is connected to the Syrah switch interface 23. It's associating with the default VLAN, and we're starting to learn about that device and say, okay, it's a Dell computer. It has a reverse DNS name of Daphne. Now I can do a mini port scan and find out, gee, this device responds to Telnet and SSH. So there's something in there listening for that. And I can click here and it will launch the browser's Telnet or SSH client so I can start interacting with it. Also, if Nmap is installed on the computer, we integrate with Nmap so that you can say, do a full scan here. Here's the Nmap command we're going to run. And it looks like Nmap is starting to show that this computer is some sort of Microsoft computer. Okay, so we can start fingerprinting that. In our case, though, we don't even need to bother with the Nmap because we know, because we're integrated with Microsoft Active Directory, we know that Daphne is a member of the Active Directory domain. Therefore, we're going to show a domain link. You can click here, and we're going to show that this is actually a Windows 2016 server. It's running VMware. We get to see a live look into CPU, memory, disk I/O, network I/O, and who's logged in. We get to see the rights of each of these users to determine what is the risk profile of what's going on. We get to see the processes to see who's running what on that computer, along with the CPU utilization, I/O read, I/O write, as well as who kicked off which process. We also get to see all of the flows going to and from this box so we can determine, well, it looks like it's talking to some server in Chicago. Okay, that's Salesforce. That's acceptable. But it looks like it's also talking to some server in England, and that's Virgin Media. Okay, that's suspicious. So we know all about what's going on with this box, what's running on it, who it's communicating with, and if we need to, we can immediately come over here and shut down the port and thus quarantine that computer. So that's as fast as we can be with being able to do SOAR because you have all of that information right in front of you so that you can render a decision really quickly. Now, you asked previously about vulnerabilities. So here you can click on these 21 critical vulnerabilities. It's going to show us all of the devices. Here we have a Cisco ASA. It's running 8.2 Rev 1, and we've identified a critical vulnerability. We can click on details, and we'll be able to see all of the vulnerabilities along with the CVE ID, the full description, the publish date. You can click on the CVE ID. It goes straight out to NIST, so it talks about that specific defect so that you can say, okay, here's the vendor advisory on what to do to remediate that. So all of the information to be able to resolve the vulnerabilities in your environment. We also look at exposures. So we analyze the network to determine, hey, you've got 143 unencrypted HTTP servers. That's a bad practice. You've got Telnet in use. That's a bad practice. You've got 9 uncontrolled DNS computers on your network. Uncontrolled DNS is, these are guys going straight out to the internet and they're not using your corporate DNS infrastructure. So that Daphne computer, for example, it's going straight out to Google for its DNS lookups. That's bad. It should be using the corporate DNS. Last thing I'll touch upon is our ability to look at geographic views. So here we can see that there's 19 flows going to Nigeria. we can click in and end up seeing all of those communications and find out, okay, it's going to Lagos, Nigeria, and it's coming from this Calvin computer, and it's going out via SQL. So this is a SQL data exfiltration attack going on. We're going to go in and shut that down. One last thing I'll touch upon, though, I know is one last, but new devices. And I think this is something, as you were talking earlier about in the Capitol, is somebody plugs something in, how quickly can you detect it? And within 5 minutes, we're going to pop that up on the list and say, we have never seen this device before. So here's a couple of new VMwares that virtual machines we created. But if something new pops up on this list, you can get an email that notifies you and says, hey, something with Light On Technology Corporation with this MAC address just popped into your network. And we're going to tell you where it is, what it is, and you can end up connecting to it, find out maybe it has a little web server, maybe it has Telnet enabled, and you can start learning about what that device is. And you can choose to whitelist it, or you can end up quarantining it. So that's the short and sweet of what we're able to do in an automated fashion. You can have all of that type of information within the first hour of deployment. And again, the trick is the faster we can automate collecting the information and the faster we can put the pieces together, that means you solve more problems in your network and you're spending less time administrating the tool.
PathSolutions has over 2 decades of experience building network monitoring systems designed to give you total network visibility. TotalView's automation means it can be fully deployed and configured in minutes, monitoring every device, interface, and server in your entire infrastructure. And it goes deep, collecting performance, configuration, 19 different error counters, PoE, and QoS statistics on every single interface. Now, all of this information is automatically analyzed to produce plain English answers. Problems get solved faster because more information and intelligence is brought to bear. This is what total network visibility is all about, knowing more about your network than with any other solution. TotalView is easy to acquire, as everything is included in the core offering: Netflow, diagramming, path mapping, server monitoring, network automation, IPAM, cloud service monitoring, and more. Putting your trust in a monitoring system can require a leap of faith. From inception, TotalView has a more secure architecture and build process that helps to protect their customers. Contact PathSolutions today, where you can learn more about their competitive upgrade program, Total Network Visibility, rapidly deployed. Find out more at www.pathsolutions.com.